Fine aggregate, primarily sand, forms a significant portion of concrete. However, the presence of silt, a fine soil component, can impact the quality and strength of concrete. Silt, with its fine particles, affects the properties of fine aggregate. Excessive silt content can weaken the bond between cement paste and aggregate. This results in reduced concrete strength, making it crucial to regulate silt content. High silt content also increases water demand, leading to higher water-cement ratios. This increased water demand can negatively impact the durability of concrete structures. Therefore, understanding and controlling silt content is vital for ensuring the longevity and stability of constructions. Regular testing and adherence to acceptable limits guarantee optimal concrete performance. The silt content test is a simple yet crucial procedure in civil engineering. It determines the percentage of silt present in a fine aggregate sample. This information guides engineers in assessing the suitability of the aggregate for construction purposes. The test involves separating the silt particles from the fine aggregate sample. This is achieved through a process of sedimentation, where the heavier aggregate settles, leaving the silt suspended in water. By measuring the volume of settled silt, engineers can calculate the silt content percentage. This value provides valuable insights into the potential impact of silt on the properties of the concrete mix. Understanding the test procedure is essential for accurate interpretation of the results. The silt content test, while straightforward, requires precision for accurate results. First, gather the necessary equipment: a graduated cylinder, a beaker, a weighing scale, and a stirrer. Weigh a specific amount of dry, fine aggregate sample, usually 50 grams, using the weighing scale. Pour the weighed sample into the graduated cylinder and add water until it reaches the marked level. Stir the mixture thoroughly to ensure even distribution of silt particles. Allow the mixture to settle undisturbed for at least 3 hours. The silt particles will gradually settle at the bottom of the cylinder. After the settling period, measure the height of the settled silt and the total height of the sediment. Section 4. Interpreting the test results. Once the silt has settled and measurements are taken, the silt content percentage can be calculated. This calculation involves a simple formula: the height of silt divided by the total height of sediment, then multiplied by 100. For instance, if the settled silt measures 2 centimeters and the total sediment height is 10 centimeters, the silt content would be 20%. This percentage value is then compared against the acceptable limits set by building codes and standards. High silt content indicates the presence of excessive fine particles, which can negatively impact concrete strength and durability. Conversely, low silt content suggests a cleaner aggregate, potentially leading to stronger and more durable concrete structures. Section 5. Acceptable silt content limits. Construction standards and building codes specify acceptable silt content limits in fine aggregates. These limits ensure the structural integrity and longevity of concrete structures. Typically, the acceptable silt content ranges from 3% to 6%, depending on the specific application and regional regulations. Exceeding these limits raises concerns about the quality and suitability of the fine aggregate. High silt content can weaken the concrete mix, making it prone to cracking, shrinkage, and reduced load-bearing capacity. Therefore, adhering to these limits is crucial for ensuring the reliability and safety of constructions. Regular testing and sourcing aggregates from reputable suppliers contribute to maintaining these standards. Section 6. Ensuring construction quality. The silt content test plays a crucial role in ensuring construction quality by providing valuable information about fine aggregates. By determining the silt content, engineers can make informed decisions regarding the suitability of aggregates for specific projects. Controlling silt content within acceptable limits ensures the production of high-quality concrete. This, in turn, translates into stronger, more durable, and longer-lasting structures. Regular testing and monitoring of silt content contribute to maintaining these quality standards. Moreover, understanding the impact of silt on concrete properties enables engineers to make necessary adjustments to the mix design. This proactive approach ensures optimal concrete performance and minimizes the risk of potential problems. The silt content test, therefore, acts as a safeguard for construction quality and longevity.